quick recap on thermistor, and then we'll explain light-dependent resistor. So the first part for thermistor is that when the temperature increases, so remember your TR that we read, remember the TR that we talked about. So if the temperature increases, the resistance decreases. And the reason is because there's a large increase in terms of the charge carriers, and that outweighs the increase in the lattice vibration. Next, we look at the LDR. When the light intensity increases, the resistance will also reduces. So in this case, with the excess light, there will be a significant increase in terms of number of free electrons or charge carriers. That will help to explain why the resistance decreases when the light intensity increases. Let's now look at circuits that comprises thermistor and LDR, light-dependent resistor. So in this circuit here, they're connected in series. So our intention is to maximize the potential difference across LDR. In this case, to do that, if we want to maximize the potential difference across LDR, we want the resistance here to be the highest, and we want the resistance here to be the lowest. So for resistance here to be the lowest, we want the temperature to be high. For the resistance here to be high, we want the light intensity to be low, so that the resistance of LDR is high, so that the potential difference across it could be high. Now in the second example that we have both the thermistor and as well as the LDR in parallel, connected to an external resistor R. And in this case, we will work out the effective resistance of this. And in the same vein, what we want to do is to maximize the potential difference across the light-dependent resistor. So the effective resistance of this is given as per the expression here. So the idea is that if you want to maximize the potential difference across here, we want the R effective to be high. In order for R effective to be high, we will want the resistance of the thermistor to be high, so that the 1 over RTR could be a small value. And in order for this to be high, the temperature will have to be low. In the case of the light-dependent resistor, we want the resistance of the light-dependent resistor to be high as well, so that 1 over R LDR is actually low. So in this case, we still like to have the low, we will want the light intensity to be low. Okay, let's give a slight twist to the question. Now, instead, we want to maximize the potential difference across R. To do that, we now want to make sure that the R effective of the LDR and the thermistor must be low. So in order for that to be low, the 1 over R effective to be high. So to do that, we want to make sure that 1 over TR is a high value. So the resistance of the thermistor has to be low. In order for the resistance of the thermistor to be low, the temperature needs to be high. In the case of the light-dependent resistor, we also want the light-dependent resistor to have a low resistance. So in this case, the light intensity must be high.